The length of an arc of a circle is a little bit hard to measure if we have straight measuring tools like rulers and so forth. It's a little bit hard to measure, but we can calculate it if we know something about the radius of the circle and the angle. Here's something we already know. We already know that if we have an angle of 1 radian, the arc length is the same as the length of the radius of the circle. That's the definition of what a radian is. But what we want to know is, what if I have some other central angle of the circle? We'll call it theta. So if you haven't run into theta before or lately, it's a Greek letter, and treat it like an x. It's just a variable. Somebody decided somewhere along the way we should use Greek letters as variables when we're talking about angles. So we do. Nobody asked me. I don't know why. So anyway, if I have some other angle, theta radians, what's the length of the arc? I also don't know why we call arc length S, but we do. It's standard from some other language, if I had to guess. So we've seen this kind of idea before. It's proportional, the arc length over the angle, the arc length over the angle. The arc lengths aren't the same, but the ratios are the same. So this is a proportion. We can treat it like any other proportion. We can cross multiply top of one by the bottom of the other. So I have S times 1 equals R times theta. And there's how we can calculate arc length. If we know the radius of the circle and the measure of the central angle, we can calculate the arc length. One really important feature right here, R is the angle in radians, or sorry, not R. R is the radius. Theta is the angle in radians. If your angle is in degrees, change it to radians. Critically important. For example, picture a pie. I have a 30-degree slice of a pie that has an 8-inch diameter. I'm not trying to be tricky or anything here. If you bake, this is how we talk about pies, by the diameter, not by the radius. So an 8-inch diameter pie, first thing I'm going to do here is notice that means the radius is 4. I have a 30-degree slice. That's nice. Can't use it. Have to change it to radians. So you may know off the top of your head what 30 degrees is in radians. You may not. Let's convert. 30 degrees, I'm going to multiply by, to change to radians, pi over 180. And I'm going to get, that's pi over 6 radians. Once we know those two things, the radius of the circle and the angle measure in radians, it's a quick hop to find the arc length. The length of the crust side of my piece of pie is radius times the angle in radians. And I get, if I reduce, 2 pi over 3, which is exact, but not very relatable. So exact value, 2 pi over 3. Approximation, which comes from a calculator, this is about 2.1 inches. Verify if you want.